Hi everyone, this is Kalyan Kumar with another video on IUPAC nomenclature of different types of organic compounds. And today we have the mother of all videos. We're looking at polyfunctional compounds, compounds in which we have polyfunctional group. That means multiple functional groups. So what happens when you have various types of functional groups in a particular carbon chain? So for that, the remedy is we are going to prioritize functional groups based on some particular logic which probably is nothing to do with reactions themselves, but they have been categorized based on a certain logic, and the category is based on from higher priority to lower priority. And if you have a group of higher priority, that is taken to be the principal functional group. So when an organic compound contains two or more different functional groups, then a higher ranking functional group is selected as the principal functional group, while other groups are treated as substituents. To decide the ranking of functional group, we follow the table that I'm going to show you now. On going down the group, the priority order of functional group decreases. So let's get on with the table. And this is how the functional groups are going to be arranged. Functional groups, suffix and prefix. Suffix tells you what would happen if this were the only group present. And prefix tells you what would be the name of this particular functional group if it were not the principal functional group. So that would be the prefix. The group which has the highest ranking is carboxylic acid, COOH. Now, when it is spoken as a suffix, we already know that if it is an acyclic thing, we call it oic acid. If it is a ring thing, we used to call it carboxylic acid. We even call it carboxylic acid when there are more than two COH group present in an acyclic chain. So the endings could be oic acid or carboxylic acid. You need to probably note all of these things down as you see the video, because it's only when you have all the listings that you'll be able to understand which one should be given preference, which is suffix and which is prefix. And if at all the COH becomes a prefix, we call it carboxy. Carboxy is the prefix for this. The second one here is the sulfonic acid, SO3H. And as a suffix, it will end as sulfonic acid. And as a prefix, it will be sulfocarboxy. Sulfocarboxy, that covers the entire SO3H. And remember that if you are looking at carboxy, if you look at the prefix here, carboxy, this carboxy includes the carbon of COH. Alright, the next one is anhydride. RCOOCOR. And we already have done the naming of this. We used to call it alkanoic anhydride, and both the alkanoics are written down alphabetically. So it's oic anhydride. Now, what would be it as a prefix? Now, for example, let's understand that if this R were to have somewhere in the end COH, obviously COH has a higher preference. So the parent would be the one that includes a COH. So how would we name this as a prefix? The prefix is going to be that if we are going to start numbering from this COH, we're going to end, let us say this is the last number P. This C has to be included in that. And this part becomes the substituent attached at the P position. And this will be alkanoyl oxy. The R C double bond O is alkanoyl oxy. So this totally becomes alkanoyl oxy, where in the alkanoyl you will include this carbon as well. And this particular carbon, the C double bond O, will be called oxo. If you remember, we have done that in aldehydes and ketones. If they were to act as prefixes, they would be called oxo. So it would be P alkanoyl oxy, and P also has oxo. Of course, we have to write everything in alphabetical order, and then it will end with oic acid or carboxylic acid, depending upon whether it is a ring or an acyclic situation. So if this is going to act as a prefix, it is going to be alkanoyl oxy and then oxo. Obviously, the numbering has to be done here. The next one on the list is ester, RCOOR. And we already have done the naming. It is alkyl alkanoate. But if it is cyclic, then it is alkyl carboxylate. So the suffix is alkyl alkanoate or carboxylate. Now what would be the prefix? Now it all depends upon where you're coming from. For example, let's again look at this R. Suppose we have somewhere in the U chain of R a COH. This takes precedence. We keep numbering from here, and the numbering stops here at P. This becomes the substituent attached at the pth carbon. And this, as we did here, is alkanoyl oxy. So if this is the substituent, it is alkanoyl oxy. Now for all you know, you could have the COH attached somewhere here on this particular R. So this becomes the principal carbon. So here you're going to number it till here. So let us say this is carbon number P. So this is now going to be alkoxy, just like an ether. So alkoxy is attached to P, and P also has oxo. So that is how we talk about the prefixes. So alkoxy carbonyl or alkanoyl oxy. When I say alkoxy carbonyl, you can, this is alkoxy carbonyl. You can call it alkoxy carbonyl, or you can call it alkoxy oxo. But when you say alkoxy carbonyl, it includes this carbon. The next one, thioethers, thioesters. We rarely see these, and they follow just like the esters. Now let's get the list going. It's a huge list. It's going to take some time. And the next one is acid halide. In the case of acid halide, how does it end? Alkanoyl halide. And if it is in a ring, we used to call it carbonyl halide. So alkanoyl halide or carbonyl halide, if it is a ring, as a prefix we call it halocarbonyl. Halocarbonyl. The next one is amide. And we've already done the naming. We used to call it alkenamide or cycloalkane carboxamide. So carboxamide or amide. And if this is going to act as a prefix, we call it carbamoyl. So remember, you got to learn all of this and remember the order. Then comes cyanide. And we know it used to end in nitrile or carbonitrile depending upon acyclic or cyclic. And if it is a prefix, it's cyano. The next is aldehyde. We know it used to end in L or carbaldehyde depending upon acyclic or cyclic, and as a prefix oxo. Ketone. We know it used to end in -one, no matter whether it is ring or acyclic, and again the prefix is oxo. The next is alcohol. It ends in all, always, and the prefix is hydroxy. The next is phenol, ends in all, and we call it phenoxy if it is a prefix. Then instead of alcohol, if you have a thiol, then ends in thiol, and the prefix is mercapto. Then comes amine, and we know it ends in amine, and the prefix is amino. Ethers, on the other hand, are never used as suffix. Ethers are always alkoxy. They're always prefixes. So no suffix for ethers. And then a couple of more groups. Then you have alkene, ends in "-ine", and there is no prefix for it. Alkyne ends in "-I", no prefix for it. Alkane ends in "-a", no prefix for it. Of course, the prefix would be perhaps alkyl, alkenyl, alkynyl, if at all we have them in the side chains. And halide will be always used as a prefix, and nitro always as a prefix. Nitro is NO2. Some functional groups such as halo, nitroso, nitro, alkoxy are always treated as substituent groups. Now comes the most important part. What is the parent chain? How do we decide which is the parent chain in this? You got so many functional groups. We know the order, but then how do we follow these? Well, the parent chain is selected based on the following rules, and you have to remember all those rules in the correct order. The parent chain is decided based on the following order. The first you got to check is select that chain. First of all, decide which is the principal functional group. Look at all the functional group and find out which has the highest preference. And select that chain which contains maximum number of the principal functional group. The chain with greatest number of the principal functional group substituents. So if there is a chain, let's say a chain like this, there's some branching here, there is some branching here, there's some branching here, and you find that there is a COH here and there's a COH here, and there are no other COH. The parent chain has to be this, containing maximum number of principal functional group, no matter how many carbons you can have on any direction. Now, if you have more than one such chain, then it is decided based on which has maximum number of multiple bonds between two carbon atoms. The chain with greatest number of multiple carbon-carbon bonds. If that cannot decide, the chain with the maximum number of carbon atoms, just as we did in alkenes. If that doesn't help, then it is the chain with maximum number of double bonds. That doesn't help, then you have to give the numbers and check that the principal functional group should get the lowest number. Look at that chain. That doesn't work. The chain with the lowest locant for the multiple bonds, irrespective of double or triple. That doesn't work. The lowest locant for double bonds. That doesn't work. Then the chain with maximum number of substituents. If that also doesn't help, then the chain with the lowest locants for all the substituents. And finally, the chain whose first substituent comes first in alphabetical order. It's a huge list. There are 9 points in this. So you got to memorize them, understand what each of them mean, and use these in the following examples. And in this particular video, we're going to do lots and lots of examples, lots of complicated molecules. So you need to have the order right with you. You need to have all the rules with you. Only then you will be able to do it. So I suggest you pause the video now, go back to all the rules, all the priority order of functional groups, go back to all the rules that I've just told you about, write them down, try and memorize them. It's only after that that you should actually try and attempt doing any question, naming any particular compound. Anyway, so I'm going to start naming compounds now. I'm going to give you some compounds. I want you to name these compounds and figure out, as usual, pause the video once the structure is shown and name it according to your logic, and then play it back to check whether your answer is right or wrong. The first one coming your way. Well, I'm trying to keep this simple a little bit. Now, the question is, which is the principal functional group? I have amine and I have alcohol. Now, if you look at the list, alcohol comes before amine. So, alcohol is the principal functional group. So, the entire name will end in all. And the numbering has to be done so that since there is no branching here, there is no problem in finding out which is the parent chain. You have to look, the numbering has to be done from that side where OH gets the least number. Now, if I say 1, 2, 3, 1, 2, 3, either way, the carbon with the OH gets 3. So, that doesn't work. So, what we would do is, we will like to give the substituent the lowest number. We number it from the right side. 1, 2, 3, 4, 5. So, this is going to be, so first write the parent, pentane, 3 all. And what is the prefix for NH2? It's amino. So, it's 1 amino, pentane, 3 all. Let's go for the next one. Yeah, pretty complicated here, right? So, pause the video, do your naming, and then come back. So, let's name this now. Which is the principal functional group? We have got two of them. We have got carboxylic acid, we got sulfonic acid. And if you remember, carboxylic acid is always number 1. So, our functional group, principal functional group is this fellow. And we will be starting the parent chain from this carbon. Now, which should be the parent chain? Well, the first point doesn't work because there is only one principal functional group. Second point says maximum number of carbon-carbon multiple bonds. Well, you don't have any carbon-carbon multiple bonds. So, the third point says maximum number of carbon atoms. And I guess maximum number of carbon atoms can only be found in this chain. And obviously, the carboxylic acid carbon will get number 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And as far as the side chain is concerned, 1, 2. And what was the prefix for SO3H? It was sulfocarbonyl. But first write the parent. The parent is pretty simple. Parent is decanoic acid. And at position 5, we have 1 sulfocarbonyl ethyl. 1 sulfocarbonyl, or rather sulfocarboxy ethyl. The 2 carbon atoms there. And then dodecanoic acid. It's 5,1 sulfocarboxy ethyl dodecanoic acid. Let's go for the next one. Now remember, there is an acid here. Anhydride here. Acid wins over. So, it is the acid which is going to be the principal functional group. Now, you have to include this carbon in the numbering. So, the numbering will start from carboxylic acid, 1, 2, 3, 4, 5. Now, what substituent do you have in 5? This fellow. And what do we call this as? Remember, alkanoyl oxy. Alkanoyl oxy. So, which alkanoyl is it? There are 2 carbons here. Ethanoyl oxy. So, it's 5 ethanoyl oxy, ethanoyl oxy, and 5 oxo pentanoic acid. 5-ethanoyl oxy 5-oxo pentanoic acid. Let's try one more. You have an acid, you have an ester. So the parent chain has to go from here and it will go up to this carbon. You have to include this carbon. So number it 1, 2, 3, 4, 5, 6. Now 5. Okay. You go up to 5 here. The reason I'm not going to 6 because is that in the ester, remember, we said if you number this as 6, then you got to say 6-methoxy 6-oxo. Or if you number only up to 5, then you have to say methoxycarbonyl, if you remember. So there are two ways of doing this. So since I've numbered till 5, I'm going to call it methoxycarbonyl sitting at 5. So 5-methoxycarbonyl pentanoic acid. Okay, let's get some more molecules now. Identify the principal functional group. It is this one. And if you follow all the rules, there's only one way that you can select the parent chain. Maximum number of carbon atoms. No multiple bonds, nothing. Numbering from the carboxylic acid carbon 1, 2, 3, 4, 5, 6, 7, 8. So it's octanoic acid. That is your parent name. In 2 you have amino. In 5 you have hydroxy. Let's number this side chain. 1, 2. And remember, when acid chlorides were the prefixes, we used to call them as halocarbonyl. So halocarbonyl is sitting at 2. So this is going to be called as 2-halocarbonyl ethyl. Then you have amino. Now this 2-halocarbonyl ethyl is sitting at 3. Amino is sitting at 2. At 5 you have hydroxy. So these are your prefixes and ends with octanoic acid. 2 amino, 3 2-chlorocarbonyl ethyl, 5 hydroxy octanoic acid. One more. You got ester and you got anhydride. And remember, anhydride wins over. So, how do we name an anhydride? We call one of them as alkanoic, the other as alkanoic, and then we say anhydride. So, this is definitely ethanoic without any issue. Now, this has to be numbered. So, 1, 2, 3, 4, 5. Now, remember, in this case, I am numbering even this. Otherwise, I can still call it, if I number only till 4, I can call this entire thing as methoxycarbonyl. But since we've already done that, I'm using a different version now. I'm numbering this 5 and I'm going to call it oxo. So, write the name of this acid, this anhydride. So, this is going to be ethanoic, 5-methoxy, 5-oxo pentanoic anhydride. Ethanoic, 5-methoxy, 5-oxo pentanoic anhydride. Let's try one more. I got an ester, I got an amide. And we know that ester is a superior functional group over amide. And what do we call this as prefix? It's called carbomoyl and it includes this carbon. So, it's going to be ethyl, alkanoate, and the numbering 1, 2, 3, 4, 5, 6, 7 maximum of carbon atoms. So, on 4 I have carbomoyl. So, this is going to be ethyl, 4-carbomoyl, heptanoate. Ethyl, 4-carbomoyl, heptanoate. Let's try one more. Now I got amide and cyanide, and if you remember, amide is a principal, it's more important than cyanide in terms of functional group. So this is the principal functional group. So I'm going to start numbering from here. And what is the parent chain? Look for the parent chain. Maximum number of carbon atoms. 1, 2, 3, 4, 5, 6, 7. And this is called cyno, remember. So this is 1, 2. This is the numbering of the side chain. 1, 2. So this is going to be alkanamide. So alkan is heptanamide. And the prefix is 4, 1 cyanoethyl heptanamide. 4, 1 cyanoethyl heptanamide. Now, let's get some more. The more examples we'll do, the better it becomes. You got an aldehyde and you got a cyanide. Which is the principal functional group? Obviously the cyanide. To start numbering from the C of the cyanide and go for the maximum number of carbon atom because there's no carbon-carbon multiple bonds. So 1, 2, 3, 4, 5. On 2 you have oxo and ethyl. And remember the name ends with nitrile. It's alkane nitrile, pentane nitrile. So it's 2 ethyl, 2 oxo, pentane nitrile. Try this one. Now I have got an aldehyde and ketone. Which has a higher preference? The aldehyde does. And go for the maximum number of carbon atoms, if not maximum number of substituents, etc., etc. So the parent chain is 1, 2, 3, 4, 5, 6, 7. Now here I am not going up to make 5 and 6 number of carbons are less. So it's 4 you have ethyl, 6 you have 4 you have ethyl, 6 you have oxo, 5 you have methyl, and it's going to be heptanyl. Remember it's aldehyde. 4 ethyl, 5 methyl, 6 oxo, heptanyl. Try this one. As you can notice, there are 2 ketones. They are the only functional groups present. So when the principal functional group is present more than once, select the chain with maximum number of principal functional groups. And number it from the side so that both of them get as low a number as possible. And here the principal chain is 1, 2, 3, 4, 5, 6. Now, the numbering actually should have been the other way around because we want to give the substituents the lower number. So instead of this numbering, the correct numbering should be 1, 2, 3, 4, 5, 6. Because in either case, the ketones are coming at 2 and 5. So the numbering that I have written with a red pen, that is the valid numbering. So this is 1, 2, 3, 4, 5. It's pentyl. So it's 3 pentyl. Though it will appear as 4 pentyl, it is 3 pentyl hexa 2,5 dione. Okay, so make the corresponding changes here. Try this one. Got an acid, got an acid, got an acid here. Remember 3 acids? And if you look at their alpha carbons, all alpha carbons are in one chain. So remember how we used to do this? We used to call them as tricarboxylic acids and not use the carbon of the carboxylic acid for numbering. So it's going to be 1, 2, 3. The reason I'm starting this as 1 is because 2 of the alpha carbon are sitting at 1. So how do we name this? It's 2 amino, 3 hydroxy, propane, 1,1,3 tricarboxylic acid. 2 amino, 3 hydroxy, propane, 1,1,3 tricarboxylic acid. Some more. You got alcohol, you got Cl, you got ether. Obviously, alcohol is the principal functional group. So 1, 2, 3, 4, 5, 6, 7, 8. Maximum number of carbon atoms. Now, so if you want to go for this, then the naming is going to start with, I guess, chloro, or perhaps, we have amino. So amino A. So it's going to be amino. So you got amino sitting at 6, chloro sitting at 2, ethoxy sitting at 4, and you got a lot of methyls out here, trimethyl, and then of course octanol, octan 3-ol. So 6 amino, 2 chloro, 4 ethoxy, 6, 7, 7 trimethyl, 4 propyl octan 3-ol. Try this one. Now carboxylic acid here, that is the principal functional group. Parent chain 1, 2, 3, 4, 5, 6. So 6 carbon atoms this way. And so look for the substituents. This is secondary butyl 4-oxo 5-hydroxy. And it's going to be hexanoic acid. So 2 secondary butyl 5-hydroxy 4-oxo hexanoic acid. Try this one. Obviously, it is the ester, which is the principal functional group. So it's going to start with ethyl. And parent chain 1, 2, 3, 4, 4. Now 1, 2, 3, 4. We could have gone 1, 2, 3, 4 as well. And let's understand why do we go for this one, because it has got maximum number of substituents. If you take this as the parent, you got a substituent 1, 2, 3 and 4. If on the other hand I were to take this route, that won't get 1 and 2. So this is my parent chain. So how do I number it? It's ethyl, and here the side chain numbering. It's 1 amino ethyl, 1 amino ethyl sitting at position 2, 4 chloro, 3 hydroxy, 3 methyl, butanoate. Ethyl 2, 1 amino ethyl, 4 chloro, 3 hydroxy, 3 methyl, butanoate. Try this one. You can clearly see the carboxylic acid and the anhydride part. Numbering 1, 2, 3. So what do we call this as? Alkanoyl oxy, sitting at 3. And this is 1, 2, 3. It's propanoyl oxy, and this hydroxy, the hydroxy should come first. So it's 2 hydroxy, 3 propanoyl oxy, 3 oxo propanoic acid. So let's do some more. More practice, better it is going to be. Name this one. 2 cyanides, it's a dinitrile. Include both the carbon atoms. So this is going to be 1, 2, 3, 4. It's butane dinitrile. Try this one. Again, carboxylic acid, principal functional group, no issue there. 1, 2, 3, 4, 5, 6, 7, 8. We need 8 carbon atoms. 5 you have cyano, 6 you have oxo, 4 you have hydroxy. This fellow is butyl and is octanoic acid. 3 butyl, 5 cyano, 4 hydroxy, 6 oxo, octanoic acid. Alright, try this one. You have aldehyde, you have ketone, you have alcohol, you have amide. Amide wins. So numbering 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be octanamide. And then you have all the prefixes you want. You got amino, hydroxy, chloro, 2 oxos, 4-amino, 5-chloro, 6-hydroxy, 7-8 dioxooctanamide. Alright, try this one. Now I have multiple bonds. We got a carboxylic acid now. Now carboxylic acid, the parent chain should include maximum number of multiple bonds, and if that being same, maximum number of carbon atoms. So the parent chain is this. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. So the parent is non-3-inoic acid, and the prefixes would include hydroxy, and you will also have 3-amino but-1-inyl. So 3-amino but-1-inyl, 5-hydroxy, non-3-inoic acid. Now let's try one big one. And immediately you can notice the carboxylic acid. Look for the parent chain. 1, 2, 3, 4, 5, 6, 7, 8, 9. Why did I go this way? I could have gotten more carbon atoms this way. Remember, we also have to have maximum number of carbon-carbon multiple bonds. That's the first priority before maximum number of carbon atoms. So now it's a game of prefixes. And this is going to be 1, 2, 1-methyl ethinyl. Oh, I got one more 1-methyl ethinyl. So it's going to be bis. Hydroxy, amino, ethoxy, ethyl, 7-oxo. Put all of them in alphabetical order. Six 1-amino, 2-ethoxybutyl, 5-hydroxy, 2,4-bis, 1-methylethinyl, 7-oxo, non-8-inoic acid. On position 6, you have this entire thing. And what do you call this? 1-amino, 2-ethoxybutyl. On 5, you have hydroxy in the parent chain. 2,4-bis, 1-methylethinyl, 7-oxo, non-8-inoic acid. And let's do one more, last one, biggie. Take your time doing this. And I guess you must have guessed it, there's carboxylic acid involved here. So remember, this is the main one. This acid is ethanoic acid. So it's going to end in ethanoic acid. And of course, in this ethanoic acid, you have got this O, this entire substituent. This entire thing is a substituent and ends in ethanoic acid. Now you don't have to number this as 1 and 2 because anything which is sitting on ethanoic acid will have to sit on carbon 2 only. In carbon 1 you cannot have any substituent. So let's try to get the name of this giant substituent, and its numbering obviously has to start from this fellow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Because we need to get maximum number of carbon-carbon multiple bonds. So I'm going to start with 3-fluoro, 4-hydroxy, and in 5 I've got I think I would need to number this, the numbering of the side chains. 1, 2, 3, 4, 5, 6, 5. Okay, this is carbomoyl. Okay, this is carbomoyl. So I have, let me see. Yeah, fluoro sitting at 3, hydroxy sitting at 4. This is going to be called 1-hydroxy, 5-carbamoyl pent 1N3-inyl, and in one I have this entire thing. Okay, so what am I going to call it? It is alkanoyl oxy. So this is on 2 I have now this is 1 2, it's 2-oxoethylamino. So look at the name, it's pretty confusing. Remember, it's going to end at ethanoic acid, and this entire thing will end at whatever alkanoyl oxy. 3-fluoro. Let's get the name first and then I'll explain each and everything to you. 3-fluoro, done. 4-hydroxy, 5, 1-hydroxy, 5-carbamoyl pent 1N3-inyl, 2 2-oxoethylamino trideca 7,9-di-N-11-ine oil oxy, ethanoic acid. So that is the names of polyfunctional compounds. I hope this video helped you in understanding how to name a polyfunctional compound. If you still have some queries or any questions, any doubts, please drop them in the comment section below. And I hope you were able to use this video for your benefit. Thanks for watching.